Hi guys, this is Quack, and today I prepared GRE 19th Quantitative Question. The category is a numeric entry as we talked about quantitative 18 question, and the specific topic is a fraction and arithmetic representation. Today's question is a little bit longer than previous questions, so I will give you 5 minutes guys, then pause the video and please think about solution, which way is it very good for you to get a proper solutions by using a sheet of paper and a pencil instead of using just a brain. So let's get it, guys. Then let's read the question again and underline important factors with the red one. Working alone at its constant rate, machine A produces T liters of a chemical in 20 minutes. So it seems to be like a kind of velocity because in 20 minutes they produce T liters. So like T liter per 20 minutes. Working alone at its constant rate, machine B, right now they talk about machine B. So with a different color. They can also make the T liters of their chemical, but it takes 15 minutes. So about the B, like a T liters per 15 minutes. How many minutes does it take machine A and B working simultaneously? Working simultaneously could be very important, which means that simultaneously means they work together at their respective constant rates to produce T liters of the chemical. So finally, what they are asking is if machine A and B work together, how many minutes does it take to make T liters? So I would like to say this question is really similar to or related to physics, such as if there is a distance and if the velocity is constant without no acceleration, in that case, distance is the velocity multiplied by time, or the velocity equals distance divided by time, or time equals distance divided by velocity. So like this way, it's a GRE mathematics question. However, we could say this types of question is really similar to asking velocity, time, or distance. Because in this situation, we can think of distance as a produces or product. And velocity is here. And then time, right now they are asking the time. How many minutes? So could it be this one? And then we can, in a proper situation, we can use 3 equations or formulations. It could be really beneficial. So let's move on to the next step. So guys, like these types of question, as I emphasize every time, the more important thing is to analyze the sentence instead of approaching, to find a specific formulation. So let's try to write down slowly here. Machine A, T liters per 20 minutes. Machine B, T liter per 15 minute. It could be velocity. And then we can change it a little bit. Let's just remove the liter. Liter. And then liter, because it's the same one. So what we can do is velocity, and then time could be velocity A plus velocity B as a denominator, and then numerator could be produces. Totally, how much do we have to produce by using a machine and machine B? It's the same as a T. Is it correct? Yes, right. Or T liter. But we don't have to worry about the liters because with the same liters, we already reduced all of them, the measurement. So we can think about like this way. But the left side should be time. And this one is just the amount of liter. So let's write down like this way. In that case, T, small t, we can remove, and then we can unify those denominators. Let's move on to the left side, guys. So like this way. So the minutes could be, guys, time. The minute could be 60 over 7 minutes. However, we should specify with the integer. So we can calculate like this way. So around 8.571 minutes. So the answer is 8.571 minutes. However, the reason why the answer is complicated is I changed the whole number, all the minute and the liters. So that's why it has a complicated answer. However, if at the real GRE question, they will let us know how much we can specify. Does it make sense? Such as 8.5 or 8.6. So they will let us know. So you don't have to worry about it. For example, we could think about the same question in a different way. Let's write down as a number 2, and then let's change minute, the 20 minutes to 30 minutes. In that case, the calculation could be easier. Again, the velocity of A to make the product could be like a T liters and then 30 minute. In that case, what about B? T liters per 15 minute. We can think like this way. In that case, time could be VA plus VB as a denominator, and numerator could be like just a T. in that case, we can, especially denominator part, we can unify it. Again, if we write it different way, it could be like this way. In that case, we can get the accurate minutes as a 10 minutes. So as we adapted the question, if the machine works like a 30-minute and B works like a 15-minute, in that case, if both of them are working simultaneously, to make the T liters of the chemical, it can take 10 minutes. So there is no problem, and then we don't have to worry about the calculation. So today's question was about the fraction and specifically arithmetic representation, because from the sentences we had to understand what we have to figure out ultimately, and we had to make our own formulation or equation. So I want to focus on more arithmetic representation ahead of numeric entry, category, because anyway, if we make the correct formulation and if we get the accurate calculation, in that case, it's pretty easy for us to approach the proper answer. So I don't worry about it. But what I'm a little bit worried about is how to approach to make our formulation and how to understand the specific sentences. So guys, it was very important, and please review the arithmetic and fraction and about the velocity, please, because we can encounter very diverse similar questions in the future, and it's going to be really beneficial for you when you encounter a little bit different types of GRE quantitative question. And guys, please click the subscription and like button if the content was beneficial for you guys, because for me, it could be my intrinsic motivation so that I can make the better quality of video and contents. So it's really helpful for me, guys. Thank you very much. And if you have any further questions, please let me know anytime, and have a great day, guys. See you later.